now, students, to the review sheet part 2. Let's go ahead and get started with this part 2 section. Yesterday in part 1, we did this part here, and we did this part here. So we're going to start today with page 854 and do these 3 numbers. Then next we'll go to 864 and do these 4 numbers. Then we'll go to page 912 and do these numbers here. So without any more hesitation, let's go ahead and get started. Okay, number 11 is a 3 variable system, and the directions say to solve the system. So here we go, let's solve this. Remember what I've taught you guys. First of all, you want to eliminate either your x's or y's or z's. But if you'll use common sense, look at this equation right here. It's already missing a y. So I already have one equation that does not have a y. All that I need is one more equation that does not have a y, and then I'll really be doing well. So I'm going to take these 2 equations here, add them together, and the y's will cancel. So x plus 2x is 3x. Y plus negative y cancels out. Z plus c is 2z. 6 plus 3 is 9. So students, look what I have. I have 2 equations with 2 unknowns, and we definitely know how to solve these, okay? I can either use linear combination or substitution. I'm going to use linear combination. I mean, look, I've got a positive 3 and a negative 3. All that I have to do is go through and change all of my signs in this equation, or go through this equation and change all the signs. It really doesn't matter. I'm going to do the top. So this 3 becomes negative, the z becomes positive, and the 0 here, you can make it positive or negative. It really doesn't matter because it's 0, okay? So let's go ahead and combine these. These cancel. Z plus 2z is 3z. 0 plus 9 is 9. Divide both sides by 3, and z equals 9, okay? Now, you can take any of these equations that have an x and a z and put 9 in for z and solve for x. It doesn't matter if you use this equation here or this one. It really doesn't matter, okay? I'm going to use this one right here because it's good. It's really plain, easy to see. So 3x minus 9 equals 0. Bring your negative 9 over and make it positive. And actually, I made a mistake. I'm sorry, guys. Z would equal 3. There we go. So 3x right here minus 3 equals 0. Okay? Bring the negative 3 over and make it positive. 3x equals 3. Divide both sides by 3. X equals 1. Now, you can put 1 in for x and 3 in for z in this equation here or this equation here. It does not matter which one, okay? I'm going to use the top equation. So x plus y. And you might say, Mr. Earhart, why did you choose the top equation? Well, guys, it just looks easier. The second equation's got a 2x. This is just x, y, and z. Plus, they're all positive, so it looks pretty easy. For x, I'm going to put a 1. For y, I'm going to put y. For z, I'm going to put 3. Combine your like terms. 1 plus 3 is 4. So y plus 4 equals 6. Bring your 4 over, make it negative. Y equals 2. So there we go. The answer is 1, 2, 3. Alright. And let's continue on. Next would be number 17. Okay, now this one's not quite as easy. You've got to decide, students, whether it's easiest to eliminate your x's, y's, or z's. Totally your decision, okay? I would think y's or z's are the easiest because with the x's, first of all, they're all positive, which makes it a little more difficult. Secondly, you've got a 1, a 2, and a 3. But over here, I've got y's that are ready to eliminate here and here. And I've got z's that are ready to eliminate here and here. So it really doesn't matter. I'm going to eliminate my z's, okay? That's my choice. So I'm going to take this equation here. I'm going to take this equation here. And I'm going to add those 2 equations together, okay? 2x plus 3x is 5x. Positive y, negative y. Actually, I'm going to be able to get rid of 2 variables. I didn't mean to do that, but it's great. I wasn't even thinking about that. So your y's cancel. Positive y, negative y, your z's cancel. And 7 plus 5 is 12. Alright, so there we go. So now we're left with x equals 12 fifths. x is. So I'm going to go ahead and put x in for, I'm going to put 12/5 in for x right here. Okay, and watch what happens when I do that. 2 times 12/5 plus y minus c equals 7, okay? So I get 24 over 5 plus y minus c equals 7. Alright, now bring this over and make it negative, and you end up with y minus c equals, let's see, what would that be? 7 minus 2 and 4/5, is that right? 10, that's 14 over 5, no, 4 and 4/5. So 7 minus 4 is 3, and then minus 4/5 will be 2 and 1/5. So 2 and 1/5. So students, where this x is right here, I put 2/5, okay? Now, I'm going to go ahead and put 12/5 in for x here, or here, really doesn't matter which one. I'm going to do the second one. Mr. Earhart, why are you doing that? Because I want to get an equation that has a y and a z. So think about it. If I put something in for x, then the x is gone, and I'm left with the equation as a y and a z. Now I can do that again in another equation, and I will get out an equation that has only a y and a z, okay? So I'm going to do that right over here. X equals 12/5. We've got to remember that. Okay, my second equation here where the x is, I'm going to put 12/5, and then minus 2y plus 2z equals -9. Alright, let's bring this over and make it negative. Bring the 12/5 over and make it a negative 12/5. And we're left with negative 2y plus 2z equals, let's see, negative 4 would be negative 13 and 4/5. So here's what I have, students. I have an equation here. That has a y and a z for its unknowns. I have an equation here with a y and a z. So we should be able to solve this pretty quickly, okay? We're going to put this over here, and now you choose. We can eliminate your y's or your z's. I'm going to multiply the bottom equation by 2 to eliminate my y's. So I'm going to multiply this equation by 2, and I get out 2y minus 2z equals, let's see, 22 over 5, so 4 and 2/5. Okay, and then bring this top equation over. Now you're going to see in a second it really doesn't matter how well I can add these fractions, because look at this. Your y's cancel, your z's cancel. You're left with 0 equals some number over here. I really don't care what the number is, because when all of your variables cancel out and you're not left with 0 equals 0, because 0 equals 0 is infinite answers. When all of your variables cancel out and you're left with 0 equals some number, then the answer is automatically no solution. So the answer to number 17 is no solution. Okay guys, let's move on to number 23. The directions are the same. We're going to solve this. It looks like it might be the easiest. Z's look like they're pretty easy because you have a 1z right here, but I mean 13's pretty big. 3 and 2 might work. I'm going to go with my x's. So I'm going to take these two equations here and I'm going to add them together to get rid of my x's. So I've got to multiply this middle equation by a -3 to give me a -3 right here, so my x's will cancel, okay? So I would get out -3x, -6y, positive 3z equals -15. Okay, so I took a -3 and I multiplied it through. Now my top equation would still be 3x minus 3y plus 6z equals 6. Okay, so let's go ahead and slide that down. Let's work on this. Add those two together and we end up with -9y plus 9z equals -9. So there's one equation that has a y and a z, okay? Now don't forget how you got that equation. the second and the third equations, and I'm going to do that by multiplying this middle equation by a negative 5, which will give me a negative 5 right here, which will make my x's cancel, okay? So here we go. Negative 5 times x is negative 5x. Actually, I'm going to slide that over a little bit. So negative 5 times x is negative 5x. Negative 5 times 2 would be negative 10y. And then negative 5 and negative c is a positive. 5c equals negative 25. So I took this equation here and I multiplied it. I multiplied everything by negative 5. Now I'm going to combine this equation here with this equation here, okay? So here we go. My x's will cancel. Negative 18y plus 18c equals, hold on one second, let's see, negative 18 plus 18, and then negative 18. Okay, so I added this equation here with this equation here. So now I have my other equation, students, that has an x or has a y and a z. Okay, so we'll put these two together. And here we go. Let's go ahead and eliminate our y's by multiplying this equation here by a negative 2. If I multiply this equation by a negative 2, a negative times a negative is a positive. It'll give me a positive 18y, which will cancel with my y right here. So I'm going to use a negative 2. And so I would get out a positive 18y, a negative 18z, and a positive 18. Down here, of course, in the bottom, this equation stays the same. Now, hopefully by now you're realizing we're going to have a special case here where everything on both sides is going to cancel out, okay? And here it is. Y's cancel, z's cancel, constant term cancels. You're left with 0 equals 0, okay? Now, as soon as you realize that, students, you know right away you're going to have infinite solutions for an answer, okay? And remember how I've taught you to do this. You write your answer in terms of A. So where C is, you put an A. So here's C, I'm going to put an A. So negative 18y plus 18a equals negative 18. Now I'm going to divide everything by 18 just to make it smaller. So I'm left with negative y plus a equals negative 1. And now bring the a over, and I have negative y equals negative a minus 1. So y equals a plus 1. So I'll put that right here for y, a plus 1. So the last thing we have to find now would be your x value. Alright, so here we go. Let's go ahead and really, students, we can choose any equation we want. It doesn't matter. We'll choose this way. This one has smaller numbers, so x plus 2y. What are we going to put for y? Well, y is a plus 1 minus what? C. Well, c is a equals 5. Alright, so x plus 2a plus 2 minus a equals 5. Okay, and so then we'd have, let's see, 2a minus a is 1a, so x plus a minus 2 equals 5. Alright, 2a minus a is 1a, or just a. Now bring your a over and bring your negative 2 over, and you're left with x equals, bring your a over and make it a negative a. Bring your negative 2 over, make it a positive 2, and combine it with a 5. So negative a plus 7 would be the answer for x. So we'll put that right here for x. And let's go ahead and continue on. Guys, you've got to know how to do that. It's called writing your infinite answers in terms of a, and you've got to be able to do that. Okay, now my book is showing I made a mistake somewhere, so let's see if I can find my mistake somewhere here. Let's see. 2a 2a, yes, right here, and I apologize to you. 2a minus a is a. This is a positive 2, so when you bring it over, it becomes a negative 2. So you get a 3 right here. I'm sorry about that. So we have a 3 right here, and that is the correct answer. Okay, moving on to number 39. Number 39. Let me look at what page we're on, page 864. And here we go. Okay, we're going to graph this. And students, I'm going to go very fast. This is pretty much algebra 2. And so here we go. 2x plus y equals 2. Using the double intercept method. Now notice, this is a linear equation. And a linear equation, I know that because my exponent of the x is a 1 and my y is a 1. And the same thing down here. So we have 2 linear equations. So I'm going to use the double intercept method where I quickly put a 0 in for x. If I put a 0 in for x, I get out a y of 2. If I put a 0 in for y, I quickly get out x equals 1, because if there's a 0 here, then I have 2x equals 2. Divide both sides by 2, and I have an x-intercept of 1. So, y is 2, x is 1. Now notice there's no equal sign under the inequality, so we're going to use the dotted line. Next, students, you have to know whether you're going to shade this way or this way, so we test a point, okay? And the best point to test whenever you can is 0, 0, as long as 0, 0 does not lie on the line that you're graphing, and obviously it doesn't, it's right here. Okay, so where the x is, I'm going to put a 0. So 2 times 0 plus y, which is 0, is greater than 2. Well, 2 times 0 is 0 plus 0, 0, 0 is greater than 2. Well, that's false. 0 is not greater than 2, so this point right here is false. It does not work. So why would you want to shade where the points are false? You wouldn't want to do that. You shade where the points are correct. So we're going to shade on the other side of this line. Okay? Alright, moving on now to the other equation. Excuse me, I'm going to do the exact same thing again. 6x plus 3y equals 2. Where the x is, I'm going to put a 0. 6 times 0 is 0, 0 plus 3y is 3y. So 3y equals 2, divide both sides by 3. And y equals 2/3. Okay, so there's your y-intercept, 2/3. Now, let's see here. Let's go ahead and move to the top equation here, which we've not used yet. I'm sorry, that's incorrect. We're going to use the same equation. However, now instead of putting a 0 in for x, we're going to put a 0 in for y. So where the y is, we'll put a 0. 3 times 0 is 0. So 6x plus 0 is 6x equals 2 divided by 6. And we get 1/3. So we have a point here. A x-intercept of 1/3, so right there. And then a y-intercept of 2/3, which is right there. Okay, so here we go. Now students, at this point in time, you should notice that these two lines are really looking parallel. Okay, which is okay, it's not a big deal, but the only way to know really if two lines are parallel or to check their slopes, and the only way to check these two lines' slopes is to get y by itself. So trust me, if you get y by itself in this equation and y by itself in this equation, the two lines do have... Okay, I'm back now, guys. Sorry about that. I think I moved the microphone away from my mouth. Okay, I'm back now. Let me start over. Sorry about that. Hopefully you're noticing here that the two lines are parallel, okay? And so, if you're noticing that, or at least it looks like they're parallel, well, the only way to know for sure is to check their slopes, okay? So, what you would have to do here is get y by itself. And if you get y by itself here, you're going to see that the slope is -2. And if you get y by itself here, you're going to see the slope is also -2. So they do have the same slopes, thus these two lines are parallel, okay? So let's go ahead and see where we're going to shade on the second line. Let's go ahead and test 0, 0. So here we go. I have 6 x. 6 times 0 plus 3 times 0 is less than 2. Well, 6 times 0 is 0, 3 times 0 is 0, 0 plus 0, 0, 0 is less than 2. That's true. So, this point right here is true. So you're going to want to shade where that point is. So, I hope you see at this point in time, the answer is very simple, very simply, no solution. Okay? And I know that because one line is saying to shade up here, and the other line is saying to shade down here, and we're looking for the intersection point where all of these lines agree, and there just isn't one, okay? So the answer to this would be no solution. Okay, moving on to number 41. Number 41. Now notice, students, first of all, that we have an x, a y squared, and not an x squared. Well, that is going to be a parabola, okay? Now you're used to having the x squared and the y not squared. And so your parabolas open up or they open down, okay? But this is pre-calc class, so we throw some curveballs at you. It's still going to be a parabola, but because the y is squared and not the x, it's either going to open to the left or it's going to open to the right, okay? So let's go ahead and get a sketch of this first graph right here. I mean, to me it's pretty simple. Whatever you put in for y, you're going to square it and get out some different numbers here. Let me show you what I mean. Okay, let's start off with 2. If I were to put a 2 in for y, I would get out a 4 for x. However, if I put a negative 2 in for y, I would also get out 4 for x, because negative 2 squared looks like this. Just like that. Negative times a negative is positive. Now, let's try a 1. If I put a 1 in squared, I get out a 1. Put a negative 1 in squared, I get out a 1. Well, of course, 0 is going to give me out a 0 no matter what. Let's try one more. Let's try 2. Alright, actually put the 2's in for the y's. Put a 2 in for the y. Actually, sorry guys, I apologize. It'd be a 3, wouldn't it? Yeah, we used 0 and 1 and 2. So let's put 3 and negative 3. So I'm going to put a 3 in for y, and I would get out a 9. If I put a negative 3 in for y, I would still get out a 9. So you're seeing hopefully kind of the idea here. Here's 0, 0, 1, 1, 1, negative 1, over 4 and up 2. See here, 4, negative 2. And then lastly, 9, 3. Well, 9's way over here, so I'm not going to worry about sketching that, but hopefully you get the idea of what the parabola would look like. And so here we go. And notice it is a dotted parabola, okay? It is dotted. Alright, there we go. Now, guys, we're going to want to test. Actually, it should come all the way over here to 0, 0. But anyways, we now need to test a point to see where we're going to shade, okay? Either we're going to shade inside the parabola or outside the parabola. Now, I can't use 0, 0. I cannot use 0, 0 because 0, 0 falls right on this parabola, okay? So, I'm going to choose a point like this right here. 0, 4, okay? 0, 4. So where the x is, I put a 0. And where the y is, I put a 4. 0's greater than 16. Alright, that is not true. So this point here is false. So I'm going to shade inside the parabola. And I would encourage you not to shade yet, just to put the arrows so you know where you're going to shade later. Alright, now let's take a look at the last equation. Now do notice there's a linear equation. I know that because I have a 1 here with my x and a 1 here with my y. Okay, so it's linear. So I'm very quickly just going to put a number in for x and get out a y and be done with this. Do that a couple of times and we're good. I'm going to go ahead and put in, for x I'm going to put in a 1, a 0, and a x right here, put a 1. Bring the 2 over, make it a negative 2. A negative 2 and 1 is a negative 1, so when you put in a 1, you get out a negative 1. Okay? When you put in a 0 for x, bring the 2 over, make it a negative 2. Y equals negative 2. Okay, now we'll put a negative 1 in for x right here. And so, negative 1 in for x. Bring the negative 1 over. And let's see here. Okay, put negative 1 in for x, bring the 2 over, make it negative. That would give you a negative 3. So there's 3 values to graph your other line. 1, negative 1, so they hit right here. 0, negative 2. And negative 1, negative 3. And your line would be a dotted line. So there we go. Alright, there we go. Now, we've got to test a point to see whether to shade. So I'm going to test 0, 0 because 0, 0 does not fall in this line. So, where the x is right here, I'm going to substitute a 0. Right here, less than 0 plus 2. 0 is less than 2. Okay, so that is a true statement. 0 is definitely less than 2. And so this point right here that we tested, 0, 0, does work. So the line here is saying to shade up toward this ordered pair right here. Now, students, listen. If this red line is saying to go up right here, and this line is saying to go down, then it looks like the only area we're going to be able to shade will be this little bit of a phrase right here. Alright? So, it's looking pretty good right there. Now, let's take a look at the answer key in the back of the book. And yes, that is correct. Okay, so I hope that makes sense. But that is how you would solve or graph the system. Alright, number 43. Now, students, please notice on number 43, we have an x squared and a y squared. Please listen to me carefully. You cannot always assume you have a circle. Now, trust me, on your test, I will give you equations that are either linear or quadratic so that you have a parabola or circles. But I don't want you to leave my class and think that every time that you see an x squared and a y squared together in an equation, you automatically have a circle. Sometimes you will have an ellipse, and sometimes you will have a hyperbola. Okay, and so that's a double parabola going different directions. And so, but on the test for now, I'm only going to give you circles or lines or parabolas. So your x is squared and your y is squared. So we have a circle. Okay. Now, the center is going to be 0, 0. I know that because there's no number with the x or y like this. Usually you would have x plus 5 quantity squared plus y minus 1 quantity squared equals, then we'll use this 9 right here. And the center for this equation would be negative 5. Change the sign of this number. Positive 1. Change the sign of this number here. But here, there's no number in the parentheses like a 5 or a 1. So it's understood to be 0. And here's why it is. If you put x plus 0 plus y plus 0 equals 9, okay? Well, if you were to simplify this, you would just get x squared. And if you were to simplify this, you would just get y squared. Y squared equals 9. So the center to this circle right here is going to be 0, 0, okay? Now the radius is always the square root of this number. So the radius is the square root of 9, which is 3. So let's go ahead and graph this circle. My center is at 0, 0. I go out 3. I go up 3 because my radius is 3. I go over 3, and I go down 3. Now there's an equal sign here, so it's going to be a solid circle, okay? So I'm going to do the best I can with my very inadequate drawing skills. I'm going to sketch this circle, okay? So there's my circle. Now I have to know whether I'm going to shade inside the circle or outside the circle. So I'm going to test a point. So where X is, I'm going to put a 0. Where Y is, I'm going to put a 0. This should be less than 9. Well, 0 squared plus 0 squared is 0. 0 is definitely less than 9. So 0, 0 does work. So we're going to shade inside the circle. Alright, now the next problem, hopefully you can see, the next equation is going to be a circle. Alright, so because I don't have some number in the parentheses with X, I know that my center is 0, 0. And if I take the square root of 1, my radius is the square root of this number here. The square root of 1 is 1. So my center's here. I go up 1, over 1, down 1, over 1. Okay? So my circle would be a solid circle looking something similar to this here. Okay? Now I've got to test 0, 0 to see whether I'm shading outside that circle or on the inside. So I'm going to put a 0 for the x squared. A 0 for the y squared is greater than 1. Well, 0 squared plus 0 squared is 0. 0 is greater than 1. That's false. 0 is not greater than 1. Thus, this point right here with the big X on it does not work. So I'm not going to shade where that point is. I'm going to shade where the point is not. Okay, now the outer circle is saying to shade in, the inner circle is saying to shade out. So it's going to be like a donut, okay? We're going to color this part of the ring right here, okay? And so there we go. Alright, moving on to number 45. Now first of all, let's go ahead and do the easy equation first. X and Y both have a 1, so we know we can very quickly graph that linear equation. I'm just going to throw some numbers in for X real quick. I'm going to throw in a 1, a 1, 0, negative 1. So throw a 1 in for X, okay? Then bring the Y over, make it positive, Y equals 1. Put a 0 in for X. Bring the Y over, Y equals 0. Put a negative 1 in for X, negative 1, and Y would also equal negative 1. Okay, so there we go. Let's go ahead and plot those points. So I have 1, 1, 0, 0, and negative 1, negative 1, and it will be a dotted line. So I'm going to quickly just sketch this dotted line. And do you shade above the line or below it? Well, let's very quickly. We can't test 0, 0, but we can test 0, 4. So let's test 0, 4, okay, students? So where the X is, I'm going to put a 0. And where the Y is, I'm going to put a positive 4. Alright, so 0 minus 4 is negative 4. Negative 4 is less than 0. That is totally incorrect, okay? That is totally incorrect. Negative 4 is greater than 0 because negative 4 is more to the left of the number line. So this is false. So this point here is false. It does not work. So we're going to shade the opposite direction. Now students, the next equation can be pretty tricky, so please pay attention. Notice I have a y squared, but I don't have an x squared, okay? Now usually in the past, you're used to having y by itself, and then your x squared term, then your x, and then some number over here like negative 3, and that is a quadratic equation. It graphs a parabola, but here it's different. Notice if the x was squared, we wanted the y all by itself. Well, in this problem here, the y is squared, so I want to get the x all by itself. So let's go ahead and get x all by itself. 3x plus 4 equals y squared. Okay. Now, let's go ahead and bring the 4 over and make it negative. So 3x equals y squared minus 4. Now divide everything by 3. X equals 1/3 y squared minus 4 itself. Now the reason I did that, students, is now I can find the vertex of the equation pretty quickly, okay? Remember, we have a quadratic equation here, okay? A quadratic equation. So the formula we use to find the vertex is negative b over 2a, okay? Negative b over 2a. Now, there is no b term, don't get confused. 1/3 is your a term. This is your c term, is your constant term. The b term would be right here in the middle with a y, but there is no y. Oh, there's a y squared, but there's not a y only. So here's what I'm going to do. I have a for 1/3, I have 0 for b, and I have c for 4/3. Okay, so 0 for b. So I'm going to put negative 0 over 2 times a, 2 times 1/3. Now, as soon as I do that, you can easily see that I'm going to get out 0. 0 divided by any number other than 0 will be 0. Now, you're used to putting values in for the x, but remember, students, everything's backwards on these problems. Okay? I mean, usually the x, the y is by itself, and this problem the x is by itself. So everything's backwards, okay? So when I get out 0 for the vertex, that's going over here for the y, okay? And then I'm going to put in 1, 2, negative 1, negative 2. Alright, so here we go. Let's put a 2 in real quick to this equation up here, and let's see what we get out. 2 in for y. 2 times 2 is 4. Minus 0 divided by 3 is a 0. Put a negative 2 in. That's 4 minus 4. That would give you 0. Let's put a 1 in right here for y. 1 times 1 is 1. Bring the 4 over, make it as a negative 3 divided by 3 is a negative 1. If you put a negative 1 in for y, negative times negative is a positive 1. Bring the 4 over and make it negative. It's a negative 3. Divided by 3 would be a negative 1. And then for 0, put a 0 in for y right here. Square the y, square the 0, that's still 0. Then bring your 4 over and make it negative, and then divide by 3. You get a negative 4/3 or a negative 1/3. Let's go ahead and graph our parabola in green here. So 0, 2, 1, 1, or negative 1. Yeah, right there. Let's see if that's right. 0, 2, negative 1, 1. And then negative 1 1/3. 0, about right here. And then negative 1. Negative 1, negative 1 right here. And then 0, negative 2 right here. And so yeah, let's see here. Okay. Alright, very good. Now let's go ahead and test a point. I'm going to test 0, 0 because 0, 0 does not fall on the green graph, if you will. So let's go ahead and graph the, let's go ahead and test a point for the green parabola to see whether we're going to shade inside or outside the parabola. We're going to use 0, 0. So here we go. 3 times 0 for x plus 4 is greater than 0 squared over here would be 0 squared for your y. Okay, so we're going to test the point. 3 times 0 is 0. 0 plus 4 is 4. 4 is greater than 0 squared. 0 squared is 0. 4 is greater than 0. That's true. So we're going to shade down, inside, toward the points that work. So the red line says to shade downward, and the green parabola says to shade on the inside. So it looks like it's going to be everything inside the parabola. Yeah, inside the green parabola, staying below the red line there. Staying below the red line. And that should be it. Let me check the answers like I always do. And you know what? I'm getting something a little different, which is really interesting. They're saying on 45, I should shade upward on the red line. So let's check my work on the red line. I want to make sure that we do these correctly, okay? So here we go. Let's go ahead and test another point for the red line. Let's test 0, negative 4. So for the x, I'm going to put a 0. And for negative 4, I'm going to put negative 4. positive 4 less than 0. 0 minus 4 is negative 4 is less than 0. That's correct. That's right. My goodness, what was I thinking before? Sorry, guys. So negative 4 is less than 0. That's totally true. That is definitely true. So you're going to shade up toward that point. Okay, sorry about that. And so, yes, the red line says to shade up, but the green graph shows you how high up you can go. When you're shading above the red line, because the green parabola says shade on the inside, and the red line saying to shade up. So that's the area right there. Okay. All right. Number 77. Okay. Let's see if we're moving on to another page here. Not sure if we are or not. Yes, we're moving on to page 912, the chapter review. And so let's go ahead and get started. Number 77. Let me turn over there real quick, students. Give me just a second to do that. Page 912. And number 77. The directions say to solve using the elimination and then back substitution. So we're going to use matrices, okay? So we're going to use matrices. Here we go. Pretty quickly. Alright, here we go. We're going to put 5, 4, 2, negative 1, 1, negative 22. Now, I need a 0 here, so I'm going to multiply the bottom equation by 5. That'll give me a negative 5 here, and then add the equations down. You would have a 0 right here. Okay, it's that simple. So here we go. The top stays the same. 5 times negative 1 is negative 5 plus 5 is 0. 5 times 1 is 5 plus 4 is 9. 5 times negative 22 is negative 110 plus 2 is negative 108. Alright, so here we go, very simply. Look at your bottom equation right here. That's going to be 9y equals 108. Alright, divide both sides by 9. It's negative 108, and y will be negative 12. Okay, negative 12. Now, take your other equation from right here, the 5, 4, and the 2, and that would be 5x plus 4y equals 2. And so where the y is, I'm going to put a negative 12, so 5x plus 4 times a negative 12 equals 2. And then that would be 5x minus 48 equals 3. Bring that over and make that a 51, I believe. No, there's 2 here. This 2 right here should be a 2. This 3 right here should be a 2. Bring this over, it becomes a positive 48. So 5x equals 50. Divide both sides by 2, and x equals 10. Okay. So x equals 10, y equals negative 12. So your final answer would be, let's see here, this pin's not exactly doing what it's supposed to here. 10 comma negative 12. Alright, so there we go. 50 minus 48 is 2, that works. Negative 10 plus, that would be negative 22. So yes, this is the correct answer. Okay, moving on to number 81. The directions say to continue to solve using matrices and the Gaussian method. So here we go. We have a 2, and a 4, a 3, a negative 3, and a negative 2, a negative 1, no, a positive 1. So a positive 1, a negative 3, and a positive 3. Alright, this thing's still not. Alright, let's put a 1 here. And let's continue on. Okay, we want to get a 0 here, students. A 0 here and a 0 here. Let's go really fast. First thing I want to do is I'm going to multiply this top equation by a negative, then add it down to this equation. So my top line will stay the same, and my bottom line will stay the same. Okay? So here we go. Negative 2 added down, we get a 0. Negative 3 added down, we get a negative 6. Negative 1 with negative 3 will be a negative 4. second, put 2, 0. 3, negative 6, 1, negative 4. Now take this here and multiply it through. 2 times negative 2 is negative 4 plus 4 would be 0. Negative 6, negative 2 would be a negative 8. Negative 2 and 3 would be 1. Okay, so I've got one more 0 to go and I'm all done. Alright, let's take this row here and let's multiply it by, let's say, 4. And multiply this bottom row by 3. That'll give me a 24 and a 24. However, I want one of them to be negative. I want one of them to be negative, so I'm going to put a negative sign on the 3 right here. Okay, so let's go ahead and see what happens. They're going to add together these 2 rows here, so that I get a 0 right here. So my first 2 rows will stay the same. And here we go. Let's see, 4 times 0 is 0. And 3 times 0 is 0. 0 plus 0 is 0. Okay, this would give you a negative 24. That gives you a positive 24. Add them together and you get a 0. This would be negative 16. This would be negative 3. And so, let's see. So negative 16, negative 3 would be negative 19. Alright. Oh, you know what, students? Oh my goodness, Mr. Earhart really messed us up, didn't he? Yes, sir, Bob. Guys, I'll tell you what. I am getting old. And I don't know what to say, guys. There's nothing I can do except to restart the entire video. And there's no way in the world I'm going to do that, okay? So on this original matrix here, I should have had I forgot my 10, my 22, and my negative 2. So hopefully I can fix this pretty painlessly and pretty quickly, okay? So slide this over and continue on. So what I did is I made this negative and added down. So negative 10 added down here. Let's see, this would stay at 10 here. Negative 10, that would be a positive 12. And this negative 2 would stay the same. So I need to make a little more room here. And then what did I do next? Let's see. Multiply this by a negative 2 and add to the bottom. So a negative 20 plus 2 would be a negative 22. I hope that's right. And we'll leave these alone. Alright. Alright, let's see what else we can do here. Alright. Now let's see here. Next, we multiplied this row by 4 and this row by 3, so I have 48 here and negative 66 here, so positive 48, negative 66, that's going to be a negative, let's see, 18 I believe. Yep, negative 18. And the other two numbers will hopefully stay the same. And I'll tell you what, guys, if I've really messed this problem up, I'll be really upset at myself, and it looks like I did. I'm really sorry about that, but there's no way I can start the entire video over again. So let's see what we got here for number 81. And yeah, I've definitely messed this up. So, alright, hold on one second. Okay, students, I'm back. I'm really sorry about number 81 being totally messed up. I paused the video and I worked the entire problem out, and now all of these steps are perfectly correct. So, once again, I'm really sorry, but hopefully, doing it the way I did it will be okay now. So, I am going to go fast because everything's already written down, so you will have to pause the video a lot, but at least it's going to be accurate, okay? Alright, the first thing you do is you copy your matrix down like this. So, here's your coefficients right here. And here's your constant terms right here. Now remember, you're going to have to pause this problem a lot. Alright? Okay, moving on. Now, next, I said to myself, okay, I'm going to multiply this top row by a negative and add it down to the middle row to get a 0 right here. Okay, because I want to get a 0 here, a 0 here, and a 0 here. That's my goal. Okay, so that's what I did. Here's what I came up with. If you multiply a negative sign through, add it to the middle row, you'll get this right here. okay? So the only row I changed was the middle row. Next I said to myself, okay, I'm going to multiply the top row by a -2. That'll give me a -4 right here. Then I will add it down to the bottom row, and that'll give me a 0 right here. So the only row I'm going to change is this bottom row here. So multiply the top row by a -2, and then add down. If you do that correctly, you will get this right here. Okay, so now I've got a 0 here and a 0 here. The last 0 I have to get is right here. Okay. So let's see what happens. What I said to myself is, okay, if I multiply this middle row by a -4, I'll have a positive 24 right here. And if I multiply the bottom row by 3, I'll have a -24 right here. So a positive 24 here, a -24 here, and then add this middle row down to the bottom row, and that'll give me a 0 right there where the 8 is, okay? So if you multiply this row here by -4, multiply this row here by 3, and then add down to the bottom row, you should come up with this right here, okay? Take your time and do it carefully, but that's what you should come up with, alright? Now, having said that, look at this bottom row right here. I have an equation, and my equation is 19y equals -114. Divide both sides by 19, and y equals -6. -114 divided by 19 is -6. So next, I realized I had an equation here, 6y minus 4z. This should be a z right here, sorry about that. That should be a z, and this should be a z, 19z. So next I noticed my equation was -6 minus 4 equals 12. So my equation would look like this. Okay, so -6y minus 4z equals 12. See this 4 right here? There's a z here, and of course I know that z equals -6. So where the z is, I put a -6, and then I solved. -4 times -4 is positive 24. Okay, and then bring that over, make it a -24. A 12 and a -24 would be a -12. Then divide both sides by a -6, and y equals 2. Okay, so y equals 2. Now, continuing on, I noticed in this equation up here, I had 2x plus 3y minus z, or 2x plus 3y plus z equals 10. So my equation would look like this right here. And so where the x is, I put, or where the y is, I put a 2. Where the z is, I put a -6, and then I solved. 3 times 2 is 6, 1 times -6 is -6. Combine these two, you get 0. 2x equals 10, divide by 2, x equals 5, and that is the correct answer in the back of the book. Okay, moving on to number 83, and let's see what the directions say here. Is it still the same? Probably is, yes, still the same thing. So I might go ahead and pause the video, work this whole thing out the same way to make sure I don't make a little mistake in the end. Okay, students, at number 83, I have totally worked the problem out to make sure I don't make any mistakes. I will go fast, but you can pause the video as much as you need to. Okay, we're going to solve this system by using matrices, so here we go. The first thing you do is you copy down your coefficients, and then on the right side over here you have your constant terms, okay? Next, I said to myself, okay, if I could make this a negative sign here, and then add down, I would get a 0 right here, which is one of my goals. So I multiplied a -1 through, and I changed the middle row, and when I did that, I got this right here. Okay, then next I said to myself, okay, self, I would love to have a 0 here. So if I can take, I need to get a 0 here, so if I can take a -1 and multiply it to the top, -2, then add down to here and change the third row, I can get a 0 right here. So the only row that I changed was the third row, and here's what I got. I got that right there. Now next I realized I need to make this become a 0. So how can I do that? Well, I've got a -2 here and a +1 here. So if I multiplied that middle row times a 2 right here, 2 times 1 would be 2. Add that down and this would be 0. So the only row I'm going to change is this bottom row, okay? But that's what it would look like right there. Now notice everything canceled out in this bottom row, everything. That means we have infinite solutions. And remember, whenever we have infinite solutions, we write our answer in terms of A, okay? So here's what I did next, watch carefully. I took this equation, I took this line here, and I converted it into an equation. So it looks like this, y minus 2z equals 1. Now we know we always put A in for z, so z equals A, okay? So z is equal to A. I solve for y. Negative 2 times a is negative 2a. Bring the 2a to the other side, and that negative 2a becomes a positive 2a. So now I know what y equals, okay? And then, moving on, what I did then is I took this equation right here. I believe, yes, which I probably would have been better off. Well, actually, I could have used anything over here I wanted to, but I used this equation here. And so 2x plus 2y. So here's 2, and for the y right here, I put what? 2a plus 1. 2a plus 1. So 2 times a. 2 times 2a is 4a. 2 times 1 is 2. And then solve for x. So bring the 4a over and make it negative. Bring the 2 over and make it negative. 5 minus 2 is 3. And now divide everything by 2. This is exactly what you're left with, okay? Right here, alright? So there's your final answer right here. Here's your x. Here's your y. And there's your z. Okay, moving on to number 95. Let's see. Okay, on number 95, we're either saying yes or no. We're not going to actually do the procedure here. We're just the operation. We're just going to see if we can do it. And the answer is yes. You can definitely do a plus 3b, and here's why. Whenever you're adding or subtracting matrices, you have to have identical dimensions or identical orders. Well, the order of A is a 2 by 2, and the order of B is a 2 by 2. Now, if you take a 3 right here and multiply it through your matrix B, is that going to change the order? No. You just take 3 times this number, 3 times this number, 3 times this number, and 3 times this number, but you're still going to have a 2 by 2. So after you take 3 and multiply it through this matrix, you still will have 2 matrices that can be added together. So yes, this operation can be performed. Alright, moving on to number 107. The directions for 107 say perform, if possible, the multiplication. So let's go ahead and multiply these together if we can. This is a 3 by 2. This is a 2 by 3. Inside numbers match. Outside numbers are 3 by 3, so we know my answer is going to be a 3 by 3. Now on the test, you should be able to multiply matrices with and without a calculator. So this row here times this column here, we'd get 6 and 8, so 14. And then we'll take that row times this column here. And so we would have 1 times negative 2, 2 times 0 is 0, so negative 2, alright? And then take this row here and multiply by this column here, and you would get 1 times 8 is 8, 2 times 0 is 0, so 8, okay? Let's go ahead and move this row marker here down to here, right here, alright? I'm going to check real quick and make sure I've not made a little mistake anywhere. Nope, everything looks good. Alright, now we're going to take this row here times this column, so 5 times 6 is 30, negative 4 times 4 is negative 16, that would be 14, positive 14. Then this row times this column here, 5 times negative 2 is negative 10, 4 times 0 is 0, so negative 10. And then take this row here times this column here, 5 times 8 would be 40, 4 times 0 is 0, 40 plus 0 would be 40, okay? So let's make sure that that is right so far. 14, negative 10, 40. And then lastly, we'll take our other row right here and multiply it times each column. So 6 times 6 is 36, plus 0 times 4 is 0, so 36, okay? Then we take this row times this column here, 6 times negative 2 is negative 12, 0 plus 0 is 0, negative 12 plus 0 is negative 12. And then we take this row here times this column over here, 6 times 8 is 48, 0 times 0 is 0, 48 plus 0 would be 48. Let me check that bottom row real quick. 36, negative 12, 48. So yes, this is the answer, okay? Moving on to number 115. And the directions for 115 state to use a graphing utility to multiply these. So here we're using a grapher, okay? So you would type this into your calculator and you would enter it as a 3 by 2. And you would enter this matrix into your calculator as a 2 by 3. Let's say you called this matrix A, and let's say you called this matrix B. After you have entered those matrices into your calculator, you then want to hit second quit and clear your screen, and then go back into your matrices and hit enter on matrix A, and this should pop up on your screen. Then hit multiply or times. This will pop up. Then go back to your matrices and hit enter on matrix B, and this will pop up. Okay, just like that. And then multiply. Go ahead and hit enter so they multiply together, and you will get this right here. If you've done it correctly, you will get 14, 19, 42. 14, 19, 42, 22, 41, 66, 22, 41, 66, and all of these will be negative. And then, let's see, 100, let's see, 22, 80, and 66. There's the answer you should get right there, okay? Alright, moving on to number 121. The directions say to, hold on one second, let me turn over to the right page. Okay, the directions say to show that B is an inverse of A, okay? And that's probably by multiplication, I would have to assume. So, yeah, we're going to multiply these together and see if we get out the identity matrix. So, here we go. 2 by 2 times a 2 by 2 gives you out a 2 by 2. So, we take row times column, that's positive 8, negative 7. That would be 1. Then take row times this column, that would be a positive 4 and a negative 4. That'd be 0. Now take this row here. Now let's see here. This row times this column, 7 times negative 2 is a negative 14. 2 times 7 is a positive 14. So we get a 0 here. Then row times column, 7 times negative 1 is negative 7. 2 times 4 is a positive 8. So a 1 here. So yes or no. Did we get out the identity matrix when we multiply these two matrices together? The answer is yes. So these two matrices are inverses of each other. Okay? Alright, moving on to number 123. The directions say to find the inverse of the matrix. So here we go. First you find the determinant. Negative 5 times 5, negative 25. I'm going to put a positive 25. Negative 6 times 4 is negative 24. So the determinant would be 1. Now you flip 1 and you still get 1. Now next, you change the signs of these two numbers right here. Okay? Don't try to, you don't move them around. So the negative 5 becomes a positive 5. And the positive 5 becomes a negative 5. Alright? Now here, we're going to swap the numbers. So positive 4 comes up here, and negative 6 comes down here. Then you multiply the 1 through a 1 times this matrix is not going to change anything. So this right here is going to be the inverse matrix for 123. Let me check that quickly in the book, and then we will go on. Maybe, hopefully, if I can find this. Yes, we're good. Alright, moving on to number 125. And the directions say to find the inverse. Well, I've told you guys anything larger than a 2 by 2. You just type it into your calculator. So type this in your calculator, and let's pretend you entered it in matrix A, okay? Well, all you have to do then is, after you've entered this into your calculator, this matrix right here, then next, what you would want to do is you would want to go back into matrices and hit enter on, let's say, A. If that's where you put this matrix, hit enter on A, and this will pop up on your page. Then look at the fourth button on the left side going down. I believe it's the fourth. It should be X to the negative 1 button like this. Okay? If you'll hit that, that'll put a negative 1 right here. Then hit enter, and you should get this for your answer. 1 half, 1 half, 0. So 1 half, 1 half, 0. Negative 1, negative 2/3. And then negative 1 half, negative 5/6. And then 1/3. this matrix here is what you should get out on your calculator. Remember, by the way, if you want fractions, don't forget, if you have a bunch of decimals, hit math, enter, enter, and it will convert it all to fractions for you, okay? But this is the correct answer. Okay, moving on to number 131. The directions say to use an inverse matrix to solve, okay? So you're allowed to use your calculator all that you want to on these, alright? So here we go. First of all, you write your coefficient matrix here, negative 1, 2, 4, negative 7, and then x and y right here, and then 8 and negative 5 right here. Okay, students, what you would do next is you would find the inverse of this matrix here, this 2 by 2 right here, and you would then multiply it by both sides of the equation. Now, please listen to me carefully, students. I've told you before, whenever you're solving a system by using inverse matrices, you're allowed to use your calculator all you want to. So I went ahead and used my calculator, and I found the inverse matrix for this matrix here, and here it is. It is 7, 2, 4, 1 going down, so 7, 2, 4, 1, okay? So I'm going to multiply that by one side, but I must also multiply it times the other side. So that matrix will go right here, 7, 2, 4, 1, okay? Well, these cancel out when you multiply them together, leaving you with x and y. And over here, when you take this matrix times this matrix, you will get out 3611. Of course, I used my calculator on all of that. And even though it looks really weird, that is the correct answer. I checked it. So 36, 11 is the right answer for 131. Okay, let's jump on now to number 135, and let's see what the directions say for that. Go ahead and solve this matrix using inverse matrices. So here we go. Okay, students, on 135, we're going to solve this by using inverse matrices. The first thing you would do is you would go ahead and take your coefficient matrix here and put it here, then put a matrix with your unknowns, x, y, z, and then put your constant terms right over here. Now next, students, you would find the inverse matrix of this matrix right here and take that inverse and multiply it by both sides of the equation. Now, I've already found the inverse matrix using my calculator, and let me get that out here. You will get this right here going down, negative 1, 3, 2. Negative 1, 8 thirds, 7 thirds. And then 1, 7 thirds, and 5 thirds. Actually 1, negative 7 thirds, and negative 5 thirds. Okay, now I'm going to shrink that down a little bit to give me some room here. But that would be your inverse matrix, okay? So we're going to multiply this times both sides of the equation, so we'll squeeze it in here. And then we're going to take this matrix here and maybe shrink it a little bit, slide it over, and then slide this right up here. Remember, you always put the inverse matrix first, okay? So over here on the left side, these two matrices cancel out, and you're left with x, y, z. On the right side, when you multiply these two matrices together, using your calculator, of course, you will get out 2, negative 1, negative 2. I've already checked that in the back of the book. That is the correct answer. And so your answer would be 2, negative 1, negative 2 for x, y, and z, okay? Moving on now to number 143. The directions for 143 say, find the determinant. Find the determinant. So it's really easy to do. Multiply up is 10, change the sign. Multiply down is negative 32. Do not change the sign. Add those two numbers together, and the determinant for number 143 is negative 42. Okay, next, number 147. Maybe the same thing. Let's see. No, find the minors and the cofactors. Okay, so here we go. Let's go ahead and find the minors first, and then the cofactors. For number 147, we have minor 11. Okay, and so that means this number here. So we get 4. Okay, going across, next would be minor 12. Of course, it's 12 because row 1, column 2. So we cross off row 1, cross off column 2, and we're left with 7. Okay? This here would be row 2, column 1, so minor 21. Cross this off, you're left with negative 1. And then over here, lastly, we have this number here, so we're looking at minor 22. Second row, second column, left over with a 2. So there's your minors. Now remember, your cofactors are really simple, okay? You look at this number here, alright? If you add those two together and it's positive, not positive, if you add these two together it's an even number, then you don't change the sign. So 1 plus 1 is 2, 2 is even, so leave the 4 alone. Okay, let's go ahead and cofactor 12. 1 plus 2 is 3, 3 is odd, so you change the sign of this and you put a negative 7. Okay, let's go on to cofactor 21. 2 plus 1 is 3, 3 is odd, so you change the sign of this, which would be 1. Okay, cofactor 22. 2 plus 2 is 4, which is an even number, so you do not change the sign of the 2. So there's your minors. And there's your cofactors, okay? Not too difficult, but it's about ready to get difficult now. And number 149, it's going to be a little more difficult. A little more work, okay, students? So let's really be careful and take our time here. Actually, I better go back and check this answer. Make sure we got this correct. 4, 7, 4. Let's see, 4, 7, negative 1, 2, and then 4, negative 7, 1, 2. Yes, that is correct. Okay, moving on to number 149. Now, we're going to start off with minor 11. Okay, so we're going to, this number here, so cross this off, and you got to find the determinant of this 2 by 2. Multiply up, that's 0. Multiply down, that's 30. Add those together, and you will get 30. Okay, let's go on to minor 12, alright? Row 1, column 2, this number here. Cross that off. So here's your 2 by 2 matrix. 1 times 0 is 0, which is 0. Negative 2 times 6 is negative 12. So your minor should be negative 12, alright? Moving on now to minor number 13. Which is this number here. Cross this off. Here's your 2 by 2 matrix. 1 times 5 is 5, so I'll put a negative 5. Negative 2 times 8 is negative 16, so a negative 21. Alright, okay, let's go ahead and take a look at our minors for 21, second row, column 1, right here. Cross that off. Here's your 2 by 2 matrix to find the determinant of 8 times negative 1 is negative 8, so I'll put a positive 8. 2 times 6 is 12. Add those together and we get a 20. Alright, let's continue on now to minor 22. Alright, that's second row, second column, which would be this number right here. So we cross this off. Here's my 2 by 2 matrix. 1 times negative 1 is negative 1, so I'll put a positive 1. 3 times 6 is 18, so we get 19. Alright, and then for the last one for this row, let's see, my minor row 2, column 3, this number here. Find the determinant of this leftover determinant 2 by 2 matrix. 1 times 2 is 2, so I'll put a negative 2. 3 times 8 is 24. 24 minus 2 is 22. Alright, now let's go on to our last row finally, and that would be minors, minor 31. Okay, row 3, column 1, so this number here. 5 times negative 1 is negative 5, so I'll put a 5. 2 times 0 is 0, so we get a 5 right here for the minor. And then we go on to minor 32, it's third row, second column, right here. Find the determinant of this 2 by 2. That's a positive 2, put a negative 2 and a 0. That's a negative 2. Alright, and then minor 33 equals row 3, column 3, there and there. So here's our 2 by 2, negative 2 times 2 is a negative 4, put a 4. 3 times 5 is 15, so we get 19. Let me check these real quick look in the book to make sure we're accurate. 30, negative 12, 21, 20, 19, 22, 5, negative 2, 19. Okay, cofactors, here we go. Cofactor 11, 1 plus 1 is 2, it's even, so leave 30 alone. Cofactor 12, 1 plus 2 is 3. That's odd, so change the negative 12 to a positive 12. Cofactor 13, 1 plus 3 is 4, so do not change the sign of negative 21. Alright, then we have cofactor 21, 2 plus 1 is 3. That is odd, so change the 20 to a negative 20. Cofactor 22, 2 plus 2 is 4, so we do not change the sign because 4 is even. And then cofactor 23, let's see, 2 plus 3 is 5, that's odd, so take the number here, 22, and change it to a negative 22. Alright, cofactor 31, 3 plus 1 is 4, that's even, so do not change the sign of the 5, leave it a 5. Cofactor 32, 3 plus 2 is 5, that's odd, we do change the sign of this and make it a positive 2. And then cofactor 33, 3 plus 3 is 6, that's even, so we do not change the sign of the 19, we leave it 19. Wow, that's a lot of work. Okay, moving on to 151. I hope we're not doing this again. Let's see, 151. Find the determinant of the matrix. Okay, we can do that pretty handily, pretty quickly. Let's find the determinant of number. I just lost my place in my book. Hold on 1 second here. Let's see here. Okay, there we go. Let's find the determinant of this matrix here. So, let's see what we got. If you remember how to do this, students, you take the first 2 columns and you copy them over. Okay? There we go. Now you're going to multiply up 3 times. Multiply these numbers together and you get a 0. Multiply these 3 numbers together and you get negative 12. So you're going to put a positive 12. Change the sign when you're multiplying up. Multiply these together and you will get 96, I believe, 16. 96, you get a negative 96. So I'm going to put a positive 96. Now when you multiply down, you do not change the sign. Multiply these numbers together and you will get a 0. Multiply these 3 numbers together and you'll get a 40. So we're going to leave it positive 40. And then multiply these 3 numbers together and you will get a negative 18. So let me grab my calculator, add these up quickly. We can probably do it in our head. A negative 18 and a 12 will give you a negative 6. That's 90. I think it's 130 when you add those up. Yes, that is correct. 130. And finally, students, I believe it's just about last but not least, page 155. Now we're going to find the linear equation. We're going to find the linear equation of the line that passes through these 2 points. Now, you know in Algebra 2 you can find the slope, y minus y, x minus x, and the slope would be negative 2 over positive 2. So the slope is negative 1, and then use y equals mx plus b. Remember this. Choose one of your points. Where the y is, put a 0. Where the m is, put a negative 1. Where the x is, put a 0. Plus b, so b is 0. So the slope is negative 1, b is 0. So the linear equation is y equals negative 1x plus 0, or in other words, y equals negative x. There, just like that, I found the linear equation, unless I made a small mistake. But hopefully you remember all that from Algebra 2, okay? So, instead we're going to do this a little differently, okay? We're going to take this column here and make it all ones. Then we're going to put an x and a y here for these 2 entries. Then we're going to put one ordered pair here. It doesn't matter which one. And then put the other one here. Okay? Now, what we're going to do next is we're going to find the determinant. Now, students, after we actually define the determinant, let's go ahead and slide this over. So what we're going to do is we're going to find the determinant and then set it equal to 0. I'll show you here. So we take our first column, we copy it over again. Take our second column and copy it over again, okay? Now, we're going to multiply up 3 times, so we multiply up here, and we get a 0. Multiply up here, 2 times 1 is 2 times x is 2x, so we're going to put a negative 2x. Then multiply up here like this, and we get a 0. Now multiply down, and of course you get a 0. Multiply down here, y times plus 0 plus 0 plus 0 plus 2x plus 2y, you would get negative 2x minus 2y, and this is your determinant right here, and you set it equal to 0. Mr. Earhart, do you always take your determinant and set it equal to 0? Yes, always. I mean, when you're doing this kind of a problem, yes. When you're writing a linear equation using the determinant of a matrix, yes, you always take your determinant and set it equal to 0. And now, to reduce the equation, divide everything by 2. So we're left with negative x minus y equals 0. And then go through and change all the signs just to make it a little nicer looking. It'd be x plus y equals 0. Now remember earlier when I started this problem, I did it the algebra way. I think I had x equals negative y, which would be the exact same thing. If you bring this y over, you get x equals negative y. To be honest with you students, on a test or a quiz, if you left your answer like this, I would have no problem with it. If you left it like this, I would have no problem with that. If you wrote it like this, I have no problem with that. And if you wrote it like this, I have no problem with that. Okay, or you could write, bring the x over and make it negative y equals negative x. None of that bothers me, okay? Alright, I hope this homework help video has been a help to you guys. Don't hesitate to call or email if you have any questions.